Hello everyone, welcome back to the xHCI driver development series. Ladies and gentlemen, we're finally ready to start the xHCI controller again. Up to this point, we've set up and allocated all the necessary data structures and registers, and it's time to put our controller back into the running mode. So without further ado, let's get right into it. Just like when resetting the controller, we will once again use the USB command and USB status operational registers. In order to start the controller, we will simply have to write a 1 into the run stop bit in the USB command register. But we can also write a 1 into the interrupt enable bit if we want the controller to send system interrupts without our driver having to continuously pull for events. When this is done, the controller will clear the halted and the C and R bits in the USB status register. And once that is done, we are ready to go. This might be the simplest operation by far in this tutorial series. So let's now jump into the code and implement it. Today's implementation is going to be very simple compared to what we've done before. Below where we declared a function to reset the controller, we'll now create one to start it, and it's going to return a bool to indicate whether the controller was started successfully or not. Great, so the first thing we'll have to do is read the USB command register and set the appropriate bits. First, we'll write a 1 into the run stop bit that will ask the controller to start running. Additionally, we'll also write a 1 into the bit responsible for enabling controller interrupts. Now that we have the necessary bits set, let's write this new value back into the USB command register. Now we need to wait for the controller to exit the halted state, and we can do that by pulling the USB status register and checking the host controller halted bit, waiting for it to become 0. Now that the controller left the halted state, we need to verify that the controller not ready bit is also 0. So here, if it's 1, we'll return false. Otherwise, the controller has started successfully and we can return true. Awesome. Let's now go back up to the top of the file, and rather than modifying the init device function, we can finally start coding up the start device function, since the initialization is all complete by this point. In order for us to see whether or not the controller has started, we can also print the USB status register before and after starting the controller, and see the difference. Again, at this point the controller should all be initialized, and all the registers should be set up with the correct values, so we can now call our newly created function and start the controller. And that's it. Let's compile and run the project and see what we get. There you go. As you can see, the status before has the first bit set, indicating that the controller is halted, but when the controller is started, it's cleared to 0. In fact, to make it easier to see and debug later in the future as well, let's make a couple cosmetic changes and create a function to log the USB status, indicating which bits are set. Also, let's just quickly add a message saying that the controller has started here. Alright, let's go back into our header file now and add a function to our class to log the USB status register. All it's going to do essentially is read the status and go through the most important bits and log which ones are set. Great. Now let's call this helper function before and after the controller is started and see the difference. And as you can see, the host controller was halted before, but not anymore after we've started it. Now I also want to show you one more thing. If you go into your makefile, you can add this line with a -trace flag to the QEMU flags to enable xHCI traces and direct them to a file just like I've done here. Let me open up a new terminal window here and watch the xHCI logs as the system runs. When I run the project, you can see different xHCI registers being read or written, and when the OS starts up, there is a USB xHCI stop message that occurs when we stop the controller. And soon enough, we then get a USB xHCI run message indicating that the controller is started. We will cover the xHCI logs in more detail later, but for now just know that they're an excellent tool at tracking what occurs in the xHCI controller and can greatly help with debugging, especially when we get to transferring data from the connected devices. And that is it for now. We have successfully fully set up and started the xHCI controller. In the next video, we'll go over doorbell registers and how to send commands to the controller and receive events in response. And after that infrastructure is in place, we can then focus on detecting port connections and setting up real devices. But for now, I wish you a wonderful day, and until next time.